By the way, I have to say this. I forgot. There you go. So remember the first topic that we saw, okay, about light. We were talking about reflection. Okay, basically mirrors, they work by reflection. They reflect light, so we are able to see what is reflected. So, for example, if you go in front of a mirror, you're going to see yourself. Okay, if that mirror has a curvature, the way you're going to be projected and the way your eyes are going to see it, it's you're gonna see the objects are being altered. Okay, the reflection that is gonna be there is going to be is gonna make a magnification that could be greater or less than 1. So objects could actually be magnified or reduced in size. Okay, but they don't actually project an object of the same size unless we're talking about flat mirrors. Now, that is reflection, okay? So you have a surface that is a reflective surface, okay? So a ray of light is going to be reflected in the same direction, that's with the same angle that it came across, okay? So this is the thing. In reflection, light is going to strike on the reflected surface, is going to go back, okay? So you're going to be able to see an object, okay? For example, here you have this ball or egg or whatever, okay? And you're going to see like the same projection over there, okay? So you're going to be able to see it. Why? Because of that reflection of light. Now, that's how a mirror works. Now, lenses. Okay, first, let's define what a lens is. Anyone can read the definition for me, please?
Lens, a transparent object that refracts light rays such that they converge or diverge to create an image.
Okay, very good. A transparent object, okay, that refracts light rays such that they converge or diverge to create an image. Yes, we are talking about light and light rays. That means that we're going to be making use of rays diagram and an image. So how is the object going to look like after those light rays pass through the lens? That's how we're going to figure it out. Now, lenses, you have to know that lenses, they're going to work by refraction of light. The definition of refraction says that it is the bending of a wave. Okay, it is the bending of a wavefront as the wavefront passes between two substances in which the speed of the wave differs. Okay, so in other words, refraction occurs when light passes from one medium to another. Example, light ray is coming in this direction, okay? And you have a glass of water, okay? You have a glass of water over here. Okay, so let's say that this is water. So here's the thing. The light ray is coming from a medium, which is air in this case. And it's going through this other medium that is the glass of water. Inside you have water. So because we have two different mediums, air and water, that means that this light ray is passing from one medium to another, which means that both are gonna have or gonna cause a different speed on light. It's going to affect the speed at which light continues. So when this occurs, this light ray is going to bend. This is what we know as refraction. Now, I can give you the definition and that's cool, but it's even cooler if we can watch a video about refraction. So let me project something for you. Recording file. So here, the term refraction comes from the Latin verb refractio, that means to break up, okay? Because this is what it seems like, that the object is broken, okay? So, but in the end, you know, it's not true, okay? It's just like an illusion. So these lenses, okay? These lenses that we're gonna be seeing in this topic, they're going to converge light rays or diverge. So for that, I'm going to project the book now. Wait. Okay. Here in this part, it says convergent and divergent lenses. So take a look. Take a look at the shape of each lens, okay? When light rays pass through a convergent lens, which is projected here in part A, what is the shape? It looks like an almond, okay? So it looks like thicker in the middle. So these light rays, you can see over here as 1, 2, and 3, okay? They are bent inward. And here at a certain point, you can see that these light rays converge. Different from example B, okay? When light ray passes through a divergent lens, which you can see that is thicker in the edge, okay? And thinner here in the center. These light rays are bent outward. So when this occurs, it's going to allow us to, through a ray diagram, to predict how the image is going to look like. Now, well, I'm going to keep projecting the book. Okay. What are the uses for lenses? Lenses are commonly used, lenses are commonly used, it's something that I really always like to share, okay, because they're commonly used to form these images in optical instruments, okay, cameras. We're all used to cameras nowadays, okay, it's something that we love. Telescopes, I don't know how many of you love telescopes, I do, okay, and microscopes, always. I remember I was not a lab geek, okay, but I remember that I used to like so much to play with the microscope and see the different cells, the plant cell, okay, mostly. And this, okay, even us in our body, we have some transparent tissue in front of the human eye. It's gonna work like a lens, okay? It's going to converge the light, okay, toward the light-sensitive retina at the back of the eye. So here, even us, we are a lens, okay? We have two lenses in our body, okay? So a typical lens consists of a piece of glass, okay, or plastic. So that surface could be like a segment of a sphere, or it could be a flat surface, okay? But, you know, they're going to have different shapes, and those different shapes are going to allow the light to bend outward or inward. Now, over here, this is the converging lens, the one that is thicker in the middle, okay? And as you can see, it's going to show us different kind of configurations, just like we did with mirrors, okay? Now, what are the main differences that you're gonna find here? First of all, the rays. I don't know if you remember, but before, the light rays after the mirror, they were dashed lines, okay? And here, there are no dashed lines. Why? Dashed lines in graphic design, a dashed line means a line that you cannot see. So what do you see in a mirror? Imagine that this is a mirror. This is the reflective surface, okay? In a mirror, this light ray is going to strike the surface and is going to be reflected. This ray, you can see it, but what happens in the back, you're not going to be able to see it. That's why we use a dashed line in the back of the mirror. In this case, it is different because, aquí más hizo, no he usado este borrador. Okay, it is different because here light is not going to be reflected. Instead, it's going to be refracted. That means going to have an angle of inclination for that saying, and it's going to be bent. But the idea is the same. Look, from the top of the object, 3 rays. There are infinite rays, but we're going to focus on 3. So from the top of the object, parallel to the surface, it connects the lens and then passes through the focal. Okay? The second ray from the top of the object, okay, passes through the other focal, and then it goes horizontal. And then the third ray on top of the object, passing through the center of the lens over there. All the rays are going to be like that, but the configuration is going to affect the image that is being created. So here in the second configuration, you see an image that is smaller than the real object. Here you see that the image is the same size of the object. They look the same, but the difference is that this image is upside down, okay? In the configuration 4, here the same, the image is upside down, but it is, the object, the image is larger than the real object. Here the image is infinite, and here the image is larger than the object, okay? Very similar to the topics that we have been seeing. So as you can see, we're gonna need to know where is the focal, but instead of having one focal, we're gonna have 2 focals, okay? You're gonna have 2 focal points, and that is the, 2 focal points and 2F, which is actually C, okay? And you're gonna see that this topic is very much similar. Now that is for converging lenses, and this is the ray diagram for diverging lenses. You can see it's only one, okay? The image created by the diverging lens is always virtual smaller image. For example, here we have the main object over here, and we have the 3 rays that are coming out of the object. So the first ray comes from the object, okay? It strikes the lens. And as you can see, the light is going to pass through the lens. This ray this is what I was telling you before. Okay, this is, no pude, F. Okay, yeah, but this is exactly what I was, if this was a mirror, then I should be able to see this ray, okay, like this, a solid line. But it's not a mirror, it's a lens, so it's going to allow the light ray to pass through it, okay? And it's going to continue in this direction over here. But this dashed line from here comes to where the focal point is located. This is the first ray, okay? So the same idea, from the top of the object, horizontally, then it's projected to the focal and refracted in this direction. The second ray from the top of the object, okay, to the other focal. And then the point where it strikes the center of the lens is gonna be projected a dashed line over here, okay? but the rate is going to come horizontally as a solid line. This is the light ray that is going to come out of this. And the third one comes from the top of the object to the center of the lens, like that. And ideally, the point where all the three rays meet is where the image is going to be located. Very much similar to what we have been doing with mirrors. Now, you might be wondering, what are the formulas then? Let me show you. The thin lenses equation and magnification. So take a look to the formula. Thin lenses equation. I don't know if I don't know about you, but it looks like a formula that we have been using for so long. It's the same mirror equation, okay? But here we need to be careful with a few things that I'm going to point out later. And by later, I mean now. Take a look. This is the sign convention that we're going to be using for lenses, okay? So, okay, here we have converging lenses and we have diverging lenses. There are two types of lenses. So here is to define about the focal point, about the image position, and about the object's position. So when we're talking about a diverging lens, for example, okay, we're going to consider that for diverging lenses, the focal is going to have which sign? Negative.
Negative.
Negative. Okay, that's how you're going to use this table, okay, to include the signs there in the formula. And the magnification is also the same that we have been using so far. Magnification is equal to image height divided by the object's height, or also equal to negative Q divided by P. Remember that Q is image distance and P is object distance, okay? So very, very, very similar, as you can see. What's going to change? Well, it's going to change the rays. The rays are different. I mean, they are drawn in the same way that we did before, except for the solid and dashed line that I explained you why. I explained you the reasons why. So right now we're going to focus on divergent lenses. So right now, guys, as I was telling you, okay, today we're gonna focus on divergent lenses, okay? Just in divergent lenses. So we're not going to solve all this problem. You're just going to focus on the divergent lens that is mentioned in the problem. So it says an object is placed 30 centimeters in front of a converging lens. That one I don't care because we're not there yet. And then 12.5 centimeters in front of a divergent lens. Both lenses have a focal length of 10 centimeters. For both cases, find the image distance and the magnification. Describe the images. And you know me, I'm going to ask you to do the ray diagram. Yeah? Because I'm going to ask you. Okay, I'm going to ask for it. So for this example, we're going to focus just in divergent lens. Okay? So what do I know about the divergent lens? That an object is placed 12.5 centimeters in front of a divergent lens. That has, Oli.
It's the same exercise you sent.
Yeah, it's the same. Sorry. It's true that it's a guy. That one's not.
Yeah, because to copy again.
Okay, I was talking alone. Sorry, I turned off the microphone. I don't know if you heard what I said, but I was saying that yes, it's the same exercise. And the thing is that I was not going to explain the same exercise But I'm going to take advantage that you're going to have an extra class this week so I can balance both sections, okay? And yes, it's an object that is placed 12.5 centimeters in front of a diverging lens. Both lenses have a focal length of 10 centimeters. So the same idea, okay? This lens has a focal length of 10 centimeters. We need to find the image distance, magnification. We need to describe the images, and we need to also draw the ray diagram. So I'm going to end the meeting now, and you click on the same link. So the class is not interrupted when I'm explaining.